Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will review equations. So we're just looking at linear equations in this video. Linear equations have a pronumeral that doesn't have a power associated with it. So it's just an x by itself. It's not an x squared, an x cubed, anything like that. So we want to solve these equations. So to solve these equations, we want to find a number I can substitute for the pronumeral, the letter, in order to make it a true statement. So the way that we do that in linear equations, we undo everything that's been done to the pronumeral in the opposite order to BIDMAS. So why is it the opposite order? Well, it's like in the morning you put on your socks and then your shoes. So in the evening, you have to take off your shoes first because they were the last thing that you put on. You have to take off your shoes before your socks. And that's similar to what happens here. So let's look at this one here. And I included this one because it often trips up people. So what's been done to x, the pronumeral here? Well, it's actually been multiplied by -7 first, and then we've added 18 because this is a positive 18. So BIDMAS tells us that we multiply by -7 first, then add 18. So this was like putting on the socks and this was the shoes. So because adding 18 is the last thing I did to the pronumeral, it's the first thing I must undo. The first step here is to undo adding 18, and the way we do that is by subtracting 18. So when you're solving equations, this point is key. What you do to one side of the equation, you must do to the other. So if I subtract 18 from the left-hand side of the equation, I must also subtract from the right hand. And the reason I did that, because plus 18 minus 18 cancel each other out. I'm left with -7x. The negative didn't go anywhere. The negative is attached to the 7, not the 18. -7x equals 32 minus 18, which gives us 14. So now I need to undo multiplying by -7. The way I do that is divide by -7. I need to divide this side by -7 to get x by itself. Remember, what you do to one side, you must do to the other. So if I divide one side by -7, I must also divide the other side by -7. So times -7, divide -7, cancel each other out. I'm just left with x equals 14 divide -7. The answer here is x equals -2. That's the solution. Why is that the solution and no other number is the solution? Because if I take my original equation here and I substitute x for -2, so I'm going to rub out x and change it to -2. Remember, 7x means 7 times x. If I change x to -2, I get a true statement. 18 minus 7 times -2 does equal 32. Because this becomes plus 14. 18 plus 14 does equal 32. All right, let's look at this example over here. I want to undo what's been done to x. So because of BIDMAS, brackets first, I know I've subtracted 5, then multiplied by 2, then divided by 3. So when solving the equation, I need to undo things in the opposite order. Because dividing 3 is the last thing I did, it's the first thing I undo. I undo dividing by 3 by timesing by 3. They cancel each other out. So I'm left with 2 outside of x minus 5 equals 8 times 3, which is 24. Because I times the left-hand side by 3, I must also times the right-hand side by 3. So there's two ways you can solve this. You can next divide by 2, or you can expand the brackets. So here, x is subtracted 5 first, then we've times by 2. The next thing I'm going to undo is timesing by 2. So the way you undo timesing by 2 is dividing by 2 because they cancel each other out. So I'm left with x minus 5 equals 24 divided by 2. Then I need to undo subtracting 5 by adding 5 to both sides. Plus 5 minus 5 cancel each other out. I get x equals 17. That is the solution because 17 minus 5 is 12. 2 times 12 is 24. 24 divided 3 is 8. If I substitute x for 17 into the original equation, I get a true statement. All right, let's now look at equations where the pronumeral is on both sides. So remember, pronumeral just means letter in place of a number. It is the thing for which you're trying to find. So in each of these, x is the pronumeral. On both sides means on both sides of the equal sign. So here, x is on left and right of the equal sign. So we need to do these equations a bit differently. We do them by solving according to these three steps. First, you need to expand any brackets or get rid of any fractions if there are any. Secondly, you need to subtract the pronumeral with lowest coefficient, lowest number in front of. The reason we do this is each of these has x in more than one spot. We really only know how to solve equations where the x is in just one spot. So performing step 2 will allow us to get an equation where x is in just one spot, and then we can solve as normal. All right, let's look at some examples. So here we have pronumeral on both sides. There are no brackets or fractions to get rid of, so we're going to go straight to step 2. Subtract the pronumeral with the lowest coefficient. So clearly 2x has a lower number in front of than this one here. 2 is lower than 6. So what we do is subtract 2x from both sides. Now make sure you know about like terms. 6x minus 2x is just 4x. But when I'm subtracting 2x from this side of the equation, I can't subtract 2x from 16. They're not like terms. I'm subtracting 2x from 2x. And of course, 2x minus 2x is 0. They cancel out. That's why we did it. We subtracted 2x to get rid of it from the right-hand side. Now we're left with an equation in which the x is only in one spot. So 4x equals 16, just divide each side by 4, you get x equals 4. This is the solution, because if you substitute x for 4, you get a true statement. 6 times 4 is 24, 2 times 4 plus 16 is 24. Change x to 4 in this equation, you get a true statement. So let's look at this one here. 7 minus 5x equals x plus 13. So when no coefficient's written, it's just 1. X and 1x are the same. So this is actually the pronumeral with the lowest coefficient. The coefficient of x here is not 5, it's negative 5, and negative 5 is less than 1. So because there are no brackets or fractions to get rid of, I'm going straight to step 2. This one has the lower coefficient, so I'm going to subtract it from both sides. What I'm going to do is subtract negative 5x from both sides. But remember, subtracting a negative is the same as adding. What I'm actually doing here is adding 5x to both sides, because minus 5x and plus 5x cancel each other out. I'm left with 7 equals 1x plus 5x is 6x, and I leave the 13 alone. 13 and 5x are not like terms, so I can't add them. So now I just solve this as normal. I subtract 13 from both sides and then divide each side by 6. I get negative 1 equals x. People often get confused by this. Negative 1 equals x and x equals negative 1. These two are literally the same thing. So the answer is x equals negative 1. All right, let's try this equation here. So firstly, there is a fraction, so we're going to first get rid of it. This is x plus 2 divided by 5. So the way I'm going to undo dividing by 5 is by multiplying each side by 5. Divide 5 times 5 cancel out. I'm just left with x plus 2 here. So when I multiply this side by 5, I need to multiply everything by 5. I need to multiply the whole lot by 5. So now I have a bracket. I need to get rid of the bracket by expanding. So I'll leave the x plus 2 alone. The way you expand brackets, remember you go 5 times x and 5 times negative 10, which is negative 50. It's called the distributive law because you distribute what's outside the brackets to everything inside the brackets. All right, now this equation looks just like these two. I've successfully navigated step 1. I've got rid of any brackets and fractions. Now I'm going to subtract the x with the lowest coefficient. Remember, no coefficient means it's 1. So this coefficient is 1, this is positive 5, 1 is less than 5, so I'm going to subtract 1x or x from both sides of the equation. So I'm left with 2 equals 5x minus x is 4x. Now I just solve as normal, now that I've got x to only one spot. So I add 50 to both sides, then I divide each side by 4. I get 13 equals x, or x equals 13. Alright, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.